Now we're on to note card 27. This is called derivatives of inverse trig, logs, and exponential functions. So at the top of this note card, you see a whole bunch of formulas. Now, in terms of memorizing, you could memorize these formulas. I think it's kind of painful to memorize some of the functions. I think you should definitely memorize these though. All right, definitely memorize those two. Okay, and let me show you how some of these work. I'm going to go out of order a little bit. Okay. Let's start with number 4. So here, let's say y equals 2 raised to the 3x power. Okay. So if I want to find y prime, okay, what I do is I follow, this is an exponential function because the variable is in the exponent. Okay, I'm going to follow this model right here for exponential functions. It says ln of a. Okay, so this is the base. The base is considered a. Okay, so I'm going to take the ln of 2 times a to the u. That's the same thing we start with. So 2 to the 3x times, and now it says derivative of u with respect to x. Well, u is the exponent. Okay, so here's the exponent. What's the derivative of 3x? Well, it's just 3. Okay, so that would be the derivative there. And generally, we like to write coefficients in front. So this is like saying 3 times ln of 2 times 2 raised to the 3x. Okay, so that's probably how it would appear. Look at problem 6 now. Here's the a, and this whole parenthesis the u. So if I wanted to find y prime here, okay, I would take ln of a, so ln of 5, times the whole thing again, 5 raised to the x cubed plus 5x. But now I need to multiply that times the derivative of the exponent. So that would be 3x squared plus 5. If we wanted to write that a little bit nicer, we could bring the 3x squared plus 5 to the front times the natural log of 5, which is just some decimal, times 5 raised to the x cubed plus 5x power. Now let's think about the next two over here, 5 and 7. Now with log problems, okay, you have one of two choices. You can either memorize the formula or you can rewrite this as an exponential function. Okay, so I think it's easier just to use this. So here, the 10 is the base, which they're calling a there, and this whole thing is the u. Okay, so if I wanted to find the derivative here, y prime, it says 1 over ln of a, so 1 over the natural log of 10, okay, times 1 over u, well, u is cosine of x, okay, times the derivative of u. So the derivative of u, derivative of cosine, is negative sine, which is negative sine of x over 1. So if I wanted to rewrite that, well, if I think about just sine over cosine itself is tangent. So what I would have is negative tangent of x over the natural log of 10. And number 7 on here, let's rewrite the function. So I can say log base 6 of 1 over x to the 1/2 power, which means the same thing as log base 6 of x to the negative 1/2 power. Okay. And if you wanted to keep this problem a little bit nicer, you're actually allowed to move the exponent to the front. So I can rewrite this even again as negative 1/2 times log base 6 of x. It's going to make the derivative calculation much easier. So y prime, this negative 1/2 is a coefficient, it stays. Now I'm going to use my rules, this rule right here, for log functions. 1 over the natural log of a is simply 6, okay, times 1 over u, well u here is just x, so that's 1 over x, alright, times the derivative of u, which would just be 1. So simplified, this just becomes negative 1 over 2 ln of 6 times x. And that's what the derivative would be there. So now let's come back and let's talk about all of these. Now, eventually, after I get done with problems 1 through 3 at the bottom, I'm actually going to show you how they came up with these formulas. So you can develop them on your own if you need to. Okay? So, all right, let's just use the formulas here. It says find the derivative of arcsine of x squared. So what does arcsine mean? Arcsine is synonymous with saying inverse sine. It means the same thing, inverse sine. Okay. That's why these are called inverse trig, derivatives of inverse trig. So here, this is the u value. U is x squared. So what does it say up here for arcsine of u? It says u prime, so what's the derivative of x squared? It's 2x over the square root of 1 minus u x squared, u squared. So you got to take x squared and you need to square it again. So if you simplify it, it becomes 2x over the square root of 1 minus x to the 4th power. Power to a power, you multiply them. Okay. So problem 2, they wrote this as cotangent to the negative 1, which means the cotangent inverse, which I could also write as arc cotangent. Okay? And instead of writing square root of x, that means x to the 1/2 power. That's the argument of that trig function. So I'm going to use the rule for that. Okay, so I'm going to use this rule right here, arc cotangent. It says negative u prime. All right, well u, this is u now. So negative, what's the derivative of this? It's 1/2, reduce the power by 1, over, what does it say here? It says 1 plus u squared. So 1 plus u, which is x to the 1/2, squared. Right. So this is like saying negative 1 over 2x to the 1/2 power divided by 1 plus, you take a power to a power, you multiply. So x to the 1/2 times 2 is just x to the 1st. Okay. And if you wanted to make this a little bit nicer, you could simplify a little bit here and you could get a final answer of negative 1 over 2 square root of x all times 1 plus x. So that would be the derivative of that. All right. So now number 3, it says if y equals the arctan of cosine, so here cosine of x is the entire u, then dy dx, and the derivative is what? So you got to go up here to arctan, it says u prime, derivative of cosine is negative sine over 1 plus u squared. U is cosine, so this would be cosine squared. And that would be the derivative. Now, it takes a lot to memorize all of these. So what about if you don't want to memorize stuff? Here's what you can do. Okay. Let me just do one example. Let's say that y equals, let's see, we had a sine, we had a tangent, and we had a cotangent. Let's just do another sign. Let's say y equals the arc sine of, I don't know, 5x squared. Okay. Find y prime. Here's a way I can do the problem without actually having to memorize the formula. Okay? So if I rewrite this, let me rewrite this. Y equals, instead of saying arc sine, write that as sine inverse. Now, to get rid of this sine inverse, I need to write sine in front of it. Okay? By doing that, these are inverses of each other. Anything composed with its inverse cancels out. So now I'm left with sine of y simply equals 5x squared. Now let's go to our right triangle trigonometry that we love. And so there is my right angle in the right triangle. Here is the angle. The angle's called y there. Okay. And what do you know about sine? Sine means the same thing as opposite over hypotenuse. So in this case, the opposite side to that angle is 5x squared. All right. The hypotenuse is 1. Okay. Now, we might need this length, so we might as well just find it now. So for now, let's just call it A. Okay. So you know these are the three sides of your right triangle. You can actually figure out what A is. The Pythagorean theorem says if I take this length and square it, plus take this length and square it, I should get the hypotenuse squared. All right. So if we do a little bit of math here, okay, if I just want to get a squared by itself, I can subtract 5x squared squared. Okay. And if I want to rewrite that a little bit nicer, 1 squared is 1, 5 squared is 25, x squared squared is x to the 4th. So that's what a squared is. So how are you going to figure out what a is? I got to take the square root. Now normally we would do a plus or minus there, but since this is a length in a triangle, lengths are always positive in triangles, so we don't have to worry about putting the negative there. So I can replace this a with the square root of 1 minus 25 x to the 4th there. Okay. Let's come back to this now. So sine of y equals 5x squared. Let's take the derivative of this using implicit differentiation. Okay. So to find the derivative of that part, okay, it's a chain rule. So the derivative of sine is cosine, leave the inside alone, but now multiply that times the derivative of the inside. So the derivative of y is called dy over dx. Okay. Now what's the derivative of this? Hopefully you just say, well, that's 10x. Okay. Now if you wanted to get the derivative by itself, okay, you would divide both sides by the cosine of y. So here, we would get 10x over the cosine of y. But I don't want any y's in my final answer. I want to go back into x world. Okay? So look back at this triangle. What would the cosine of y be equal to? Well, here's my angle. Cosine is adjacent over hypotenuse. So the adjacent here is this side. So the length of that side is the square root of 1 minus 25x to the fourth over 1. So now I can plug this in for the cosine of y. So that's going to be 10x over square root of 1 minus 25x to the fourth power, and that is what the derivative is. Notice how it meets the same formula here, okay? It says u prime, look at the original problem, okay? Here was the u, the derivative of that would be 10x, okay, over the square root of 1 minus u squared. 1 minus 5x squared quantity squared is this. So what I do, I don't memorize these, okay? I just apply these rules when I need them. Okay. So let's kind of do another example here. All right. So let's say I told you y equals, I don't know, the secant. That's a bad one. Y equals the arcsecant of, I don't know, let's do 4x to the 7th power. So again, I can write this as secant inverse of 4x to the 7th. Well, to get rid of that secant inverse, you need to put a secant in front. So that cancels that out. So now the secant of y, you haven't taken any derivatives yet, but the secant of y equals 4x to the 7th over 1. Well, you got, sometimes secants are hard to remember. Remember that secant, all right, the secant of y, so let me draw in my angle y here, here's my right angle. Secant is the reciprocal to cosine. Cosine's adjacent over hypotenuse, so the reciprocal would be hypotenuse over adjacent. Okay? So here, the secant of y, the hypotenuse would be the numerator, 4x to the 7th, over the adjacent would be 1. Now we might need this, so call it something, call it a. So you should know that 1 squared plus a squared is going to be 4x7 squared. So if I want to solve for a squared, I could take 4x to the 7th squared minus 1 squared. Okay, so therefore a squared would equal 4 squared is 16, x to the 7th squared would be x to the 14th. 1 squared is 1. And then if I wanted to figure out what a was, it would be 16x to the 14th power minus 1 all underneath the square root. So I can replace this a with 16x to the 14th minus 1. Your whole goal is to take a derivative though. So again, you got to use implicit differentiation. Derivative of the outside, derivative of the outside, derivative of secant is secant tangent. You don't change the inside. Times the derivative of the inside. What's the derivative of y? We call that dy over dx. So the derivative of this, the derivative of 4x to the 7th, would be 28x to the 6th. So if I wanted to solve for dy dx, I would divide both sides by everything else. So I would take 28x to the 6th and divide it by the secant of y times the tangent of y. So now we can replace stuff. Okay, let's make substitutions for that. I already know that from up here that the secant of y was equal to 4x to the 7th. Okay, so I have 28x to the 6th. What was the secant of y? It was 4x to the 7th times, what's the tangent of y? How do I figure out tangent of y? Well, tangent of y, what's tangent? It's opposite over adjacent. So here, if this is my angle y, this side is opposite, this side's adjacent. So I would take this divided by 1, which would still be itself. 16x to the 14th minus 1. So this would be the derivative. So I develop it. I don't memorize things, I just develop it. Now let's see if it follows the pattern here for secant. Okay. So it says the arcsecant of u, in our case the u was 4x to the 7th, derivative, so u prime right here, so the derivative of 4x to the 7th is 28x to the 6th, over u itself. They have absolute values here to make sure it's positive. Okay. Square roots, if I take this and square it, I get this, minus 1, minus 1. So I just did 2 examples here using, I let u be different things. So I let u equal that in the first case. I let u equal this in the second case. Okay, but just develop it if you need it. And then you don't have to memorize 6 more formulas. That's the easiest way to do it. The only real formulas you should need to memorize are exponential functions and log functions. Okay, so memorize those 2. And for these other 6, develop them if you need to. Okay, develop them when you need it. All right, too hard to memorize those formulas, in my opinion. All right, so with this particular note card, there's no associated homework. If you want to practice, okay, we did sine, we did an example of sine, we did an example of secant, and maybe make your own example and see if you get a derivative that matches those forms. So you could do that as homework.